Hey there.
Hey, morning.
Yeah. Hey. Hey everyone joining. Good turnout.
All right. Well, let me pull up the slides. Um, we can get started. All right. All right. So we have a few things on the agenda today. Maybe some things are in the slides, maybe some things that aren't. I see you're here, Kyle. Felix mentioned you might have some updates you want to share with us. I don't think we have slides for that in here, but you're more than welcome to take the screen at some point if that's what you'd like to do today, or you could do it another week. Aside from that, we have just some quick reminder announcements, and we can get into the bulk of it, which is the framework updates. So we're gonna be going to a meetup in April 25th in San Francisco. If you're around, the Node.js meetup. We'll put a link once they have it up, but Robin and I are gonna go and just kind of do an overview of OpenVis and our projects and what's new. Um, and so yeah, join us if you'd like. Uh, on to the 2024 Collab Summit reminder, we have a venue and date picked. We are going to be going to London September 10th and 11th for 2 days at the Microsoft Reactor space. And we're now beginning kind of all the setup of ticket pages, website updates, those kinds of things to start to make a space for speakers to apply and talk. If you're interested in talking and coming again, reach out and we'd be more than happy to start that conversation. So then now we can move on to the framework release updates, unless there are any questions. All right. Felix, would you like to kick it off?
Yeah, so as we discussed in some previous meetings, Nebula GL is a project which has been built on top of DeckGL, which has quite a lot of users in the community, but we have been unable to contribute to the original repository, so we made the decision to move it into the DeckGL community repo. And in this last few weeks, then Ib and Don have done like a big push on updating a bunch of the code, updating it to V9 DeckGL. And we're basically at a point now where we think we can publish an alpha to NPM. The only kind of remaining decision is deciding or agreeing on how to kind of name the package. So if you could move to the next slide, Chris. Essentially what we have at the moment in DeckGL community are two kind of competing ways of doing it. One is following DeckGL style, where it's just DeckGL community / whatever the module is. And then there's a couple of layers that have been contributed with different package names and been pushed to NPM underneath that. I think the general consensus is that this DeckGL community approach is the best one to go for. As far as I can see, the only downside is that you get pretty long package names. So you might have DeckGL-community / editable layers. But at least it's clear. And I think that would be the one that I would go for.
Also have the @VisGL namespace if you don't mind going a little more official.
So @VisGL / editable layers.
Yeah.
Yeah. This is kind of similar to what I was suggesting at the bottom, putting @DeckGL.edit / editable layers, but I'm pretty sure you're not going to like that, Xiaoji.
No.
There we go. Okay, but I mean, Vis.jl is certainly shorter than DeckGL / community.
I mean, Bing Maps has never been published, so I don't think that's, you know, worth using as a reference.
No, I was just saying what was in the repo as option.
Yeah, I know. And we it's not really being used as a monorepo in the sense of we don't publish those packages at once using Lerna. Each package is managing its own publish timeline and strategies. So yeah.
Yeah, my 2 cents. First, there is at least one module, the DeckGL community layers module that has been published with the namespace, but that can obviously be changed. I think to me, it's nice to have a namespace because it shows that it's kind of semi-official. I mean, we're keeping these outside of DeckGL because we're giving a much lower level of support guarantees, but still, you know, there's some kind of vetting that goes into being part of this repo. And so, and, you know, showing it with DeckGL community next to DeckGL, you know, makes it fairly clear what's going on. A downside is if we get a lot of contributors, we're going to have to give access to this DeckGL community organization to more and more people, and it could at some point be abused to publish some crap on some of the other modules. So it's a matter of kind of trust. On the other hand, you know, we may not grant DeckGL community to every, just because a module is in here doesn't mean that, maybe that's a second level of, you know, trust that we bestow, that you get to use the namespace, whatever it is. This GL seems to me a little bit more maybe official, like, you know, and so if we want to, you know, I think it feels like a namespace that we have to stand behind, whereas on the DeckGL community, we're kind of flagging that this is not necessarily official, you know, it's good contributions by the community, but they're less, you know, supported and stable and secure. So that just thoughts, but in the end, we just need to make a choice, and I can get behind anything.
Yeah, it's also a bit vague. I mean, when it says VisGL, then is that going to be relating to DeckGL layers? Is it relating to loaders? Is it some clever Luma plugin?
I think right now the only thing published under the VisGL namespace is React Google Maps.
That is quite an official module, right?
Yeah.
It is. Well, Google is promoting it. Yeah.
We have dedicated maintainer even in this meeting, right? So.
I'm not too worried about the name being long. It's not like someone's going to like hand type it.
Yeah, and I think what is good is that if the name is literally clearly there in the package, then someone who has pulled down a project which is using the editable layers is then going to discover DeckGL community and might go and take a look and see some of the other things that are there. So I actually think that it can bring people to that place and see what else is there and get involved.
Yeah, I think the one of the reasons I'm excited about the DeckGL community repo is exactly that. It's the discoverability. So people can, because you create like a bunch of repos with different editions, and it's hard to even find them in the first place, and then to have a sense of how they fit together and if they're updated and if they support the latest version and so on is really hard. So
okay, so are we agreed that we just go for deckgl.gl/community dash community editable layers? Yeah.
Works for me.
Sounds good.
right, we have a decision.
So I think we can move on. I'm not sure if these, I only had those 2 slides that I added. I'm not sure if these are from last time.
These are from
Yeah, I didn't write the slide, but what's on my mind is that I think we're in the process of, on a high level view, the way I see it, we're in a process of moving the entire, lifting the entire VisGL ecosystem to 9.0. And, unfortunately, this has involved addressing quite a significant amount of tech debt, for instance, the forking of Nebula and stuff like that. But we're pushing through it in a impressive pace, and we're getting close to. So obviously, if we look at the repos, I mean, MathGL, ProbeGL, with the LoadersGL 4.2 just released, with all the latest build systems, and so should be fully aligned. And now Nebula is getting very close with alpha releases ready. And then I think the other part that we have is Hubble. And there was one blocker that Chris was facing, which was the WebGL 1 support in base maps. And we were able to create a workaround in Luma to trick the base map libraries to create WebGL 2 contexts. And so that should unblock the porting. And once all of those components, including Nebula and Hubble, are ready, then we should be able to attack Kepler and get Kepler upstream to V9. And I think that's so we're very close to the end of this huge V9 cycle, and hopefully that will now be a stable API where we will just do minor iterations and feature additions and so on, so we can go back to the fun work of actually building new stuff. So I don't know, Chris, if you have any thoughts on Hubble if you've done an attempt to run it on V9 yet, or I guess the Eclipse got in the way. But
yeah, right before the Eclipse, we had merged in the Luma patch that I was working on. So that now kind of paves the way to be able to do a Hubble upgrade for MapGL 1. Mapbox V1 users, Kepler being still one of them, until MapLibre has a rendering bug that's fixed. Sorry, my dog is excited.
Kepler 3 has already moved to MapLibre. So.
Oh yeah, I think MapLibre is fantastic, and I would love Hubble to just use MapLibre exclusively, but there's still that checkerboard rendering issue during interleave, and that is a requirement for Hubble to capture both canvases.
Right.
So we can schedule some time, maybe tomorrow. We can do a paired debugging. I have some tips we can look into. I suspect some WebGL state that got polluted.
Okay, yeah, let's look into it. But yeah, once that's up, issue is resolved. And kind of in parallel to that, I'm in the process of upgrading Hubble's build tools to the latest stuff as well, since I just think that everything should be up to the same bar. And I'll be able to do an alpha release soon, maybe in the next week or 2.
That'll be amazing. And I would venture that if that's true, if we get to that point, we've never been in such a good place where a maintainer can move between basically any of these repos and have the same build system and the same, conventions and the same and everything upgraded on the same version of Deck and the latest version. So, It's going to be pretty amazing. Hopefully, you know, most upgrades to V9 have been surprisingly smooth, and hopefully that's also true for him. Yeah, so you know, apart from that, then the next step is to start thinking about 9.1. Obviously, a lot of good you know, bug fixes and polish is going into 9.0, so it's stabilizing, I think, very nicely. And there's a bunch of things already in LumaGL 9.1. We could start publishing alphas, and we could start. It will trigger some updates in DeckGL, and so that work could start. I saw one of the really big things that need to be done is to move all DeckGL shader modules to uniform buffers, and one of the biggest one is obviously project. And I saw Felix, you've already started that work, so that's a big milestone.
Yeah, it wasn't actually too bad. I learned my lessons doing the picking one, so.
I think it's will be a lot easier to move other modules once the once Luma supports uniform and binding integer modules.
I think that's a pretty small lift. I think that was just an omission in the shader input. So,
yeah, it's just not there yet.
Right. But if that's what we're gated on, then maybe I can get that done.
So that's all we had on the agenda in here. We could open up to discussion. There are a couple items we could talk about. Kyle, I wanted to offer you a chance if you wanted to share anything with us this week, or, you know, there's always 2 weeks from now, if not.
Yeah, I would do a small demo of Longboard. I've been talking to Don and Felix about PyDeck and Longboard and some related things. For context, I'm working on this other binding. I'm not sure the best way to describe it, but a binding to DeckGL. And I figure having a short demo might illuminate some things and talk about how it's different than PyDeck. I'll keep this to like 5 minutes. But so this is a demo of some speed test data that I get from AWS Open Data. I already have this downloaded locally, so we can load this in a couple seconds. We get this data frame, which has 3.2 million rows. And so each of these have a download speed in kilobytes per row and a point geometry. And then we can, in about 2 to 3 seconds, we can take this data, serialize it to Arrow and Parquet on the Python side, pass it over the binary WebSocket, parse it from Parquet to Arrow in WebAssembly, decode it into JavaScript, and pass it through DeckGL's low-level binary API into the attributes way. And so it takes like a few seconds to render this. We like black points are not very interesting, but all of these attributes and accessors on the Python side are separated from the actual data. And so by focusing on moving the data really efficiently, we can not have this PyDeck DSL that we're familiar with. So it's really fast to update this fill color because this is only sending these 4 numbers across the network. But again, a single color is kind of not very interesting. So this is creating a normalized download speed between 5 kilobytes and 50, or 5 megabytes per second and 50 megabytes per second. And so we can apply this on this color map. And then this takes about a second to assign this buffer, this NumPy array of colors onto the layer, which gets encoded as Parquet and sent over the network to DeckGL, which is then passed into these layers separately. And then we can set a separate radius, a separate color, for each of these separately. We can have a tooltip. Clicking on items lets you access layer.selected index on this side, so you can do like gdf.iloc and access the row that you selected. We're working on expanding that to bounding boxes as well, so that you can get lots of data, or the data that you have in your viewport, back into Python. I wrote up this document to share at least with Felix and Don this week about how the architecture differs a lot from PyDeck. In PyDeck, you pass in a string, and maybe that's usually a URL that gets fetched on the JavaScript side, and then goes through the loaders.gl mechanism and goes through the same as if you're passing that URL into deck.gl. Whereas in contrast, Longboard really expects all of this data to come through Python for data scientists who already have data in GeoPandas geodata frames and want to do this exploratory data analysis there. And so this is part of that, is that I'm really focused on rendering from GeoArrow. I have these layers on these are pure Java or TypeScript layers that take in GeoArrow tables that are Apache Arrow objects, and don't have any intermediate data representation. They pass, it sorts out how to access the buffers in the Arrow layers and pass them into the right attributes that deck.gl is expecting, and does some validation on these as well. It also does multi-threaded polygon triangulation by passing these Arrow buffers across threads and back, so that it can do ear cut on a worker. And so that was pretty fast. I think this, like, we've been talking a bit about PyDeck, and Don's working on updating PyDeck to V9, and just like trying to understand the work that I've done and how it relates to PyDeck. It is a binding to deck.gl, but it's not like just a binding. It's a very opinionated binding of how we're able to take lots of data and move it across the network more efficiently. Where I tested this 3 million point data set from this example, and with IPyLeaflet, it took 3.5 minutes and then crashed. With PyDeck, it took 2.5 minutes and crashed, because it was trying to send this GeoJSON, which is, I think, 700 megabytes is GeoJSON, over the network, and Jupyter just couldn't handle that. Whereas this is like 30 or 40 megabytes is Parquet, and expands to like 90 megabytes in Arrow in memory. But I think that's basically what I wanted to cover, and happy to answer questions. Or
so my comment is, I think this is the right way to do Python binding. Current PyDeck uses the declarative, like JSON submodule that kind of lets you do expressions, but not all expressions, in a very limited way. And in this particular context, Python developers can't really figure out how to do that, but they can do fairly complicated things in Python itself. And I think if we move all like mapping or data processing into Python, it will be much more accessible to Python users. Second comment is, we don't really have a dedicated maintainer of PyDeck right now. Why don't we just merge the effort and make this PyDeck?
do you want to say something about that, Felix? Or we've been
basically
talking a little bit.
discussing that this last week. I mean, I agree exactly with what you're saying, Charity. Like, we want to have people maintain these projects. We have a lot of people who want to visualize data in deck.gl via Python. The question is, like, yes, if we switch to this, which is a very obvious kind of breaking change, then are we going to lose a bunch of developers who were using PyDeck and were loving the DSL for the accessors. You know, I mean, it works for some people if you come from more of a JavaScript side.
I mean, I might be naive here, but why can't we support both?
I mean, the accesses are good in case you, for instance, want to do animations or other things. I could imagine, you know, in principle, I don't know exactly how you know, but sometimes you want to evaluate things on the, I think on the JavaScript side. I mean, I totally agree that you know, making DecGL work with the data in Python is incredibly powerful. But the question is, could we? I mean, this is more complicated. This is more work. This is a more ambitious approach. So, could the PyDec approach still be there in parallel? Because the things that are hard to maintain with PyDec is like the connection to the Jupyter, and that kind of it updates in Jupyter 3 and Jupyter 4, and the communication and all of this. And all of these things you're working on actively, Kyle, and so I think having the rest of the PyDec API present somehow here would, you know, hardly be an inconvenience. But maybe it doesn't fit with kind of philosophy or style, but it seems like, or PyDec could be based on this. So this module, and then PyDec basically inherits this one and uses it for all the underlying transport, and just adds the declarative interface or something. Maybe there's a way we can make this
I might be
leverage.
wrong, but I think PyDec right now is still doing string serialization.
It has like the beginnings of some binary transport, which I played around with, but like it's nowhere near as fully built up as this, and it's going to break in Jupyter 4. So basically the approach that Don has been taking with getting PyDec working is to not worry about the kind of fancy things you can do in Jupyter and just focus on the HTML. So getting it working with that, because actually one of the biggest pain points with like making these Python environments is that you can have lots of different Python environments. Like you can have like a notebook, or it can be something in a collab, and supporting all of them is painful. We had someone just drop now. Is everyone still there?
Yeah, Ben and I have to drop. Sorry for that, but I think Chris, you're still good on the recording.
Yeah.
Okay.
Okay.
Yeah, so I was just saying that in the short term, I think it makes sense with PyDec to just support the HTML generation, because it's just, we don't have anyone to maintain the other part. And then what Kyle is doing is a very opinionated way of working with GeoArrow and a specific set. And I think some of the ideas and a bunch of the projects that you're using, like AnyWidget as well, and the one you mentioned, didn't exist when PyDec started. And pulling that into PyDec could make it easier to develop and move forward and maintain.
If there's any way to merge these two projects, we should do so. I mean, if there's an interest from your side, Kyle, and you know, we can brainstorm and see if there's anything that we can do that can, you know, preserve PyDec or make PyDec a derivative of this or whatever. Then, but I think this is the way to go. This is what being maintained. That's developing very rapidly. That's going in the right direction. And so, if this can become part of the VisGL and the spiritual successor of PyDec instead of being a kind of a side project, that would be amazing.
Yeah, I mean, I think it's good to discuss more. I think that like right now, this is under the Development Seed organization, which is the company that I'm at now. I think that in general, there's just a lot of different philosophy that I have compared to PyDec, of like simplifying my life a lot by only having a single type of data that's coming in from Python, because I control how all the data comes from Python. And so like right now, there isn't any way to pass in a URL to like a GeoJSON that would be loaded just on the JavaScript side. And so I don't have like fully formed ideas of like how this should interact with PyDeck or how to move forward, but I think, you know, just like presenting this and getting feedback and is a good, you know, this is a good discussion.
Yeah.
Exciting.
Yeah, it's a very, very cool project, Kyle. Thanks for sharing it with us. I remember seeing it a few months ago in some of your tweets about those benchmarks, and my jaw dropped.
Yeah, and I mean, it really fits with the direction where I think we've talked about for a long time about DeckGL, you know, and Luma, which would be, you know, to have more built-in arrow support directly. So right now you have like this mapping that you have to do between arrow and the binary interface, but ideally we should have like a LumaGL arrow module or a DeckGL arrow module, or maybe even building in arrow support more directly in Deck, right? So
Isn't it the case
shouldn't really
how
be
the fill layers actually just take the arrow representation directly and just render it? So you're not mapping it to DeckGL one.
No, I do map it to DeckGL layer. So like if we look, let me share my screen again. So if we look at like the scatter plot layer, I taken
Yeah, but this is the easy one.
Well, sure, it is the easy one, but I think it's still like descriptive of, I do some validation on it. I make sure that it has a geometry column. I make sure that like any accessors have the same length as the main table and stuff like that. But internally, I'm looping over each internal chunk in the table, which then has contiguous buffers. And for each of those, I'm constructing this data prop that has these attributes, get position, flat coordinate array, and then passing that into a DeckGL scatterplot layer. So I'm not creating my own layers. I'm only having composite layers that map onto that, and managing like the picking to make sure that when it picks in one layer, it actually reflects the index into the entire table that was passed in. And then expanding this so that even like the polygon layer, which is a bit more, or solid polygon layer, which is a bit more complex, because here I have this ear cut, which has a thread pool so that it passes the data onto the worker and passes it back, and handling both polygons and multi-polygons. And so here rendering this multi-polygon layer is a bit more complex, because then I map back into, I'm rendering these polygons, but have to manage the offsets between what gets rendered and what the actual logical row is for picking, which generally works, except like I never got auto highlight fully working, where the index is messed up for auto highlight. But so it is a bit of work to do this mapping, but it is, I mean, I'm just using DeckGL layers.
Kepler 3 supports geo arrow, but with a new, basically geo arrow polygon layer, but it doesn't support general arrow, because in general arrow you have to like specify which columns and stuff like that, but in geo arrow you know where to find the geometry. And so I think that would be, it would be good to have that arrow support somehow in either DeckGL or an add-on somehow, and then leverage that in. It's a little bit too much complexity, I think, for your module. That's not what your Python binding should have to spend so much time about.
Yeah, these, as a note, these are separate from the Python bindings, so they can be used directly from JavaScript. And like it was conscious to separate, like they're depended on by the Python bindings, but these are,
maybe it's almost like we could break them out into an experimental arrow layers module, and we could put that in a DeckGL community and incubate it a little bit there.
Yeah, for now I'm just incubating it in the GeoArrow org, and I mean, I think it's fine to incubate there until we want, unless we want to do something like long term.
Yeah, I suspect we will. But it's an incredible start, obviously. You have all of this already working, and it's very exacting work. So it's amazing. All right.
Yeah, as I understand today, the GeoArrow deck layers package could be imported by any JavaScript project, including Kepler, if they wanted to start to use these composite layers.
Yes, exactly. That's my point, right? We could call them like arrow scatter plot layer and arrow this and that, and have them take arrow tables directly.
All right. Well, we've definitely gone over time, but this has been very exciting. I'll see you all in 2 weeks. Let me know if you'd like anything on the agenda for the next 2 weeks, and we'll put it on.
Okay.
Hello.
Bye.